I'm going to talk about the LayoutView Pager, which is a lightweight view pager. And I just want to, first of all, just go through kind of an outline of what I'm going to talk about. I'm just going to remind you of what a view pager is, talk about what is the traditional approach which we use with fragments, then talk about a different way of thinking about view pagers, the lightweight approach. Then we're going to first look at it from the point of view of the client, and then look at the architecture, and then finally open it up to questions and any comments that you would like to ask. So this is just a screen that I grabbed arbitrarily off the web. This is what a view pager looks like. The idea with the view pager is that basically you could swipe or swipe, and you can move from view to view. And these dots here that you see, this is actually a view page indicator. We're not going to talk about view page indicators in this talk, but it does turn out that with the approach that I'm going to discuss, it works really well with, say, Jake Wharton's view page indicator that he has open sourced. However, the idea, you can see this is page 1, page 2, page 3, page 4, and so on, and you can swipe back and forth to go through all of those pages of information. The key idea to understand with a view pager is that every view pager needs to have a pager adapter. And typically what is recommended in Android is that you use a FragmentPagerAdapter or the FragmentStatePagerAdapter. The conversation that goes on between the two is that the view pager might call the adapter's getCount method, and it might concretely return 5 to say that there's 5 pages, and so the indices are between 0 and 4 inclusive. And it might say getItem 0, it will return the fragment. getItem 4, which in this case would be the last view to display, and we return the fragment. The order in which the conversation is occurring and exactly what is being, and when the calls are occurring and in what order is unimportant. What's the thing that's, the issue is that a pager adapter has to answer 2 questions. It has to answer the question, what is the order of the pages, which is implied by the indices, and how many pages exist? If it can answer both of those questions, then it qualifies as a pager adapter, which the view pager can use. Now, what we want to do and what I want to propose here is that suppose that we make it the condition that the developer states that the layouts that they want to display in the view pager should be expressed in terms of an XML. And so we're going to have an array, named pages, and then we're going to have a series of items, and we're going to have layout page 1, layout page 2, page 3, and so on. And these are references to legitimate layouts. So the question becomes, would this be enough information, if we could read the XML file, to qualify as an adapter? And the answer is, well, of course. If we can read it, we know how many items there are, 3, and we know what the order is because that's implied by the order in which they appear in the file. The other thing that's crucial to understand is this @layout stuff and @array stuff, it all at the end reduces down to integers, and we just have to do the bookkeeping in the code to keep track of all of those integers. So from that, we're going to look at how we might architect a view pager so that we can accept input like that. So how would we read the array file? One possibility is that we could suppose that we actually have written somewhere a layout view pager. We've got the ID, some style, and then in the yellow part we have this special stylable item called layouts, and this is going to point to the array of pages. And the idea is that this guy is going to pick this value up and then ultimately it's going to be able to tease this all apart and be able to figure out what are the pages that need to be displayed and what are the views that need to be displayed in the ViewPager. So this leads to this architecture, which is a lot to take in all at once, and we'll just kind of parse it apart and look at it bit by bit. In my color coding, green means that these are Android classes. So let's look at the top layer. It should come as no surprise that we're going to at least have the ViewPager class, and we're also going to have the PagerAdapter, and this is going to be some kind of abstract, it is actually an abstract class. So these classes by themselves can't have a conversation between one another because we need to fill in some of the details. In the second layer, the LayoutViewPager is going to be a kind of ViewPager, and we're going to implement the missing bits of the abstract PagerAdapter to have the LayoutViewPagerAdapter. I want to concentrate on this guy because this is the one that makes the key difference to how this works. The LayoutViewPager has two dependencies. It has the context, and it has this guy called a dataset. The two methods that get called in the conversation are instantiate item, and it will be passed in an integer for the position, and that will be done by the LayoutViewPager, as well as getSize, and that's going to return the integer representing the number of views that have to be displayed by the ViewPager. It turns out that the LayoutViewPager can't actually answer these questions directly, and that's why it's dependent on this interface called the dataset. So let's take a look at that. The dataset interface, its intention is to model the pages array. So in this particular case, when its return of getSize will be concretely 3, and when it is called for getLayoutResID for say 0, it will return essentially the integer that is allied to page number 1. That's how it's going to do it. So the two methods that are in yellow, they work together in tandem. They're the easiest ones to understand. If getSize is called, what will happen is that the PagerAdapter will simply delegate that work onto getSize in the data set. In this particular case, for the instantiate item, the PagerAdapter will be able to inflate the view. However, it needs to know which view to inflate. So it will call into this method and ask the data set, tell me what do I need to inflate, and then it will return that inflated view directly back to the PagerAdapter. However, this is only an interface. How is it actually implemented? That's what we'll look at when we look at the bottom layer. When we look at the bottom layer, the LayoutViewPager dataset, which implements this dataset interface, it actually concretely will take a resource array, and it's just an integer, which is actually the integer that is allied to this array. And what will then happen is it turns out that it's a very easy business, given the context, for the pager data set to convert this thing into what's called a typed array. And we can just think of it abstractly as being, in this case, just an array of integers. And because it's an array of integers, it knows the length and it knows what is the integer value at any particular index. And that's basically, in very short form, how it implements these two methods. So the question then becomes, though, how does the integer, that is the resource ID, the array resource, get passed into it? And that's where we put everything together. What we have to remember is that if we go back to what we said earlier, we're going to be asking the developer to write the LayoutViewPager in this way. And we're going to ask them to indicate where it can find the array of pages that should be displayed in the ViewPager. When this is encountered, our constructor is going to be called. And the constructor is going to do four very important things. It turns out that it's going to get passed to it the attribute set. And the attribute set is, loosely speaking, the hand-wavy explanation is all the stuff that's in the XML. We're not interested in all of it, but we are interested in this layouts attribute. And it turns out it's rather easy business in step number 1 to get that array ID and tease it out of the attribute set. Once that's done, and because it knows the context, both the context and the resource array resource ID are both satisfied. With those requirements satisfied, the LayoutViewPager dataset can be constructed by the constructor. Since the LayoutViewPager dataset very conveniently implements the DataSet Interface, it means that we can now pass into the LayoutViewPagerAdapter the context and this implementation of the dataset. Given these two things, and the LayoutViewPager being created, in the last step, in the fourth step, what happens is that the LayoutViewPager kind of reflexively calls setPageAdapter essentially on itself to wire these two things together so that that conversation can now begin in terms of how many pages are there and what view do you want and what view should be shown given a particular integer position. And with that, the whole thing works. Putting aside all of these details, though, and all of the bits and pieces of how this works, the real question is, did we achieve our result? And we did. The whole summary of the thing is that there's actually no coding involved to set this up. I mean, you have to obviously set up the LayoutViewPager, but once it's set up and an application can use it, all the developer has to do is two things for any application. First, put the layout reference to the LayoutViewPager wherever it's supposed to appear in whatever other parent container. And then make sure that this refers to an arrays.xml file, which in turn refers to all of the legitimate layout files which are defined somewhere else, which describe what needs to be shown. What this can do for us is that it can avoid a lot of ceremonial code. If we look at this fragment, and if we suppose that this fragment is never one that will be hosted by an activity, there really is only one salient line in all of this blah, 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 blah. And that's this single line on create view. And that's where the inflator inflates the layout as pointed to by the resource layout ID. That's all it does. However, it does it in a really back and forth way. If we're using a fragment adapter, first we're going to have to call the usual new instance boilerplate code. We're going to have to create the arguments, stuff the integer into the arguments, create the fragment, set the argument, send the fragment back. Then the lifecycle methods will have to be called. We'll then have to tease that integer out of the arguments, put it into this instance variable, and then finally, and the last gasp, the onCreateView will be created. So the argument here is that instead of going around in circles like this, why not just simply let the adapter straight away inflate the view and send it right back without further ado. So that's kind of the idea, the principle of what we've saved when we are just considering very simple layouts that which will never be fragments and never be reusable bits of UI and will only ever appear as simple pictures in our LayoutViewPager. I do need to give credit where credit is due. The inspiration for this came from Matt Compton, who is a developer at the Big Nerd Ranch, and I encourage you to go to his blog, ViewPager Without Fragments. It will show you the details of exactly what you need to do, in particular to implement the pager adapter and how you override the methods. What is original about my work is the way in which I've handled it so that the data can be read from XML files, and so there's really no code that ever needs to be changed. So that's where the novel part is added, but the inspiration certainly comes from that, and I encourage you to read his article. Okay, well, thank you very much. I appreciate your attention. Yes, and I guess we're going to take a short break while we get set up for our next talk.